Alright, so this one's a little bit of a doozy. This is part 2 of the midterm. So this one requires you to do a little bit of extra math. And algebraically, you could probably figure it out, but I'm going to try to approach it the way y'all would. So you have a senior employee that works 18 hours and earns $40.50 more than a junior employee that works 22 hours. So the senior employee makes earns $16 per hour. What is the hourly wage in dollars and cents for the junior employee? And then we'll record our answer. Okay, so the senior employee, we know, works 18 hours and gets paid $16 per hour. So if I multiply those two numbers, I'm going to do 18 times 16. I get 288. Now, I know that he gets paid $40.50 more than the junior employee. So if he gets that much more, that means I have to subtract that $40.50. And if I subtract that number, I get $247.50. So $247.50. Now, that's what the junior employee gets paid, but how many hours does the junior employee work? So the junior employee only works 22 hours. So now I'm going to take this pay and divide it by the 22 hours, because we know that's how much he gets paid, and we're going to divide it by the hours that he works. So I'm going to take that 247.50 and divide it by 22. So once I do that, I get $11.25. So his hourly wage is $11.25. And I know that can be complicated for some of y'all. So multiply the wage of the hourly rate, subtract the extra money that he gets, and then we divide it by the total hours that the junior employee worked. Alright, so number 15. So we're going to write an inequality. So inequality are these guys. It can be any four of these guys. Now, we want to make sure that we're drawing it for the solution set. So again, this is a little bit different. Since it's a horizontal line, I know that I need a y. Now usually we would say y equals, but this time we need an inequality. So hopefully y'all remember that because this is a dotted line, I'm not going to be using these two guys. I'm going to be using one of the last two. Now if you look, it's shaded below, which means I need the less than. So I'm actually going to use this guy. Now, I need this number right here. This number is -3. So there's our answer. Alright. So I kind of wrote over this one, but it says if this is number 16, if the graph of y equals 3x plus 8 is translated 12 units down, which equation describes the new graph? Okay, so it doesn't give you options, but that's okay. We can come up with our own. Now, because it's shifting down or translating down, you should know that's talking about the y-intercept. So we're going to take this equation, okay, so what we're going to do is, because it's talking about the y-intercept, I'm going to subtract 12 from this. So 8 minus 12 is -4. So my new equation is, so y of 2 is 3x minus 4. So there's our new equation. Now, check. Remember, you're going to have answer choices on your test, so it doesn't make sense for you not to check your work. So let me zoom back out. Alright, so zoom 6. Okay, so there's our original. And here's our new. So what did it translate 12 units down? Well, that's 8, 9, 10, 11, 12. So we were correct. So just make sure you're checking your answers. Alright, so which inequality represents all the values of x for y less than or equal to -6 times x minus 18 minus 2 when y is equal to 16. Okay, so they're telling us specifically that y is equal to 16. So I'm going to plug in, and at the same time I'm going to go ahead and just distribute that -6. So -6 times -18 is 108, positive. Remember, 2 negatives give you a positive when multiplying. Okay, now I'm also going to do 2 steps on this. I'm going to move this over, and when it comes over it's going to be a positive number because it's negative, and I'm going to combine these two in one step. So I have 6x plus 16 less than or equal to 106. So hopefully I didn't lose you. All I've done was move the x and change the sign. And I've did 108 minus 2, which gave you the 106. So now I'm going to subtract 106 minus 16, so 106 minus 16, and then I'm going to have to divide by 6. So my final answer will be 15. So 6x, why did I divide by 6 just a second ago? Because we want x by itself. So x is less than or equal to 15. And there's your answer. Alright. Number 18. Alright, domain range. We are going to draw lines. Hopefully you can see that these green lines are touching the x-axis at 0 and 5. So my numbers are for the x-axis. Remember, this is domain and range. Domain is x, range is y. We're gonna start. We always start off with this part. These are always going to be true. The direction of the arrows. Let me erase that. So this section will always be true. We have to decide what the numbers are and if there needs to be a line underneath. So if you can see, since there's an open circle, I don't need a line underneath. But because this is a closed circle, I do need a line underneath. Okay, so hopefully you guys understood that this is going to start just like this for the next one. We just have to determine whether or not A needs lines and B what numbers we're going to use. Okay, so it's cutting through the y-axis. I know this bottom one touches the x-axis, but it chops through the y-axis. So here it's touching the y-axis at 4, and it's touching it at 0. So our numbers are 0 and 4. And since both these lines right here don't have an open circle like this one does, then that means they both need lines underneath. Now, we talked about this on number 1. Is this a function? So if I drew a line, the vertical line test, would it ever touch more than once? It would not, so this is a function. Alright, so number 19 is going to take us a while to get done because there's a lot to this. So, several friends are working to make bracelets. Using the table, create value of scatter to create a scatter plot. Then draw the trend line and predict how many bracelets they could make after 20 minutes. Okay, so first things first, I'm going to go to stat, and I'm going to type in all these numbers. So, I need to make sure I'm in the correct column. Okay, so now I'm going to go, oh, I forgot to turn on my mode. Okay, on my mode, I need to remember to have my diagnostic on, my stat diagnostic, because that'll give us some information that we're going to need. So, stat over 4. Okay, so here are my numbers. So I need this equation. I need y equals 0.211x, I rounded to the third decimal point, plus 0.285. Now, it's asking, is there an association? Because this number is a positive number, we're going to say that it's a positive association. Now, is there a correlation? Well, the more minutes that passes by, the more bracelets that you would think would be created. So, there is a correlation. Now, I'm going to skip this for right now. I'm going to go to correlate. Having trouble saying correlation coefficient. Okay, so correlation coefficient is this R. My R is 0.89. This is where it wants you to determine whether it's a strong positive, weak positive, or strong negative, weak negative. Well, since this is a positive and it's close to 1, this is a, I forgot strong. This is a strong positive. Alright, so again, this determines this. So since this number is close to 1, it's a strong positive. If it was closer to 0, it would be a weak positive. Alright, so I'm going to use this equation to determine this right here. So I'm going to go to y equals. Now I'm going to type in 0.211x plus 0.285. And I'm going to go to second graph. And I'm going to go to 20. So this is technically 4.5 and it continues 0.5. Okay, but it wants to know how many complete bracelets you would have. We're not going to round up on this one because it's not complete, so we would actually only say that there's 4.